is lesson 5 on diffraction, grating and white light for year 13 physics. So white light is composed of different colors. So you've got all these colors. Each color has a different wavelength. Now when white light is shown through a diffraction grating, different colors diffract through different angles. Why? Because their wavelengths are different, their path difference is going to be different, and so they will have their antinodes at different angles. Hence, each order forms a complete spectrum, with red, which has the longest wavelength on the outside, and blue, which has the shortest wavelength on the inside. The path difference for red is greater than that of blue due to its longer wavelength. You need to talk about this path difference in your answer. The central antinodal line is white because the different colors all overlap as they arrive in phase with zero path difference combining to form white light. That is why the central one is white. And you have the blue on the inside and red on the outside. So this whole thing is one order, and each order forms a complete spectrum. Now a compact disc or a DVD or a Blu-ray acts like a diffraction grating. The spiral track is made of bumps on the reflective surface of the CD. Light falling on the surface reflects at different angles, undergoing both constructive and destructive interference. So this is just a magnified image of the surface of a CD. It's got these spits and spaces or lands. Okay, now how do you calculate the number of orders formed by a diffraction grating? So to find the maximum number of orders produced, we need to substitute theta as 90, assuming it can't go beyond that angle. Okay, so in other words, as theta approaches 90, sine theta approaches 1. So in this equation, n lambda is d sine theta. It becomes n lambda is d because sine 90 is 1. And so in order to find the number of orders, it is d over lambda, and you bring it to the nearest whole number. Now the fringes or antinodal lines are also referred to as maxima. Those are antinodal lines, and minima is another word that's used for nodes. So to find the total number of maxima, use 2n plus 1 because this is for monochromatic light. If for white light, the number of complete spectra is twice n because you've got fringes on either side of the central antinodal line. And yeah, and this is just a question if you like to look at for multiple slit spectrum and how I went about solving that. Okay.